Okay, let's try our alternating series test on the sum from 1 to infinity of minus 1 to the n times the natural log of n over n squared. Here the positive part of each term is given by the natural log of n over n squared. And first of all, we'd like to check the limit as n goes to infinity of that positive part. Well, the limit as n goes to infinity of the natural log of n over n squared is the same as the limit as x goes to infinity of the natural log of x over x squared. And this is an indeterminate form, both numerator and denominator are going to infinity, so we can use L'Hopital's rule. So it's the limit as x goes to infinity of 1 over x over 2x. Of course, that's equal to 0. So the first condition of the alternating series test is satisfied here. Next, we need to check if Bn is decreasing as n increases. And once again, we can replace the n by x in the expression for Bn and calculate the derivative of the resulting function. So looking at f of x equals the natural log of x over x squared, f prime of x is x times 1 minus 2 times the natural log of x over x squared. X squared is positive, and when x is greater than 1, x times 1 minus 2 times the natural log of x is less than 0, whenever 1 minus 2 times the natural log of x is less than 0. And that is whenever 1/2 is less than the natural log of x. So applying the exponential to both sides, we get that that happens whenever x is bigger than e to the power of 1/2, or the square root of e. And this certainly happens when x is bigger than or equal to 2. So when x is bigger than or equal to 2, f prime of x is less than 0. This function f of x is decreasing, and therefore the bn's are decreasing because bn is fn. So since the bn's are decreasing as n increases, the second condition of our alternating series test is satisfied, and we can conclude that this alternating series converges.